One.
We're Gator parsers, and we're updating on our work for DSLs for algebraic Julia, and I'm Dylan Zhao.
And I'm Christian Scaff.
So to continue where we left off, our project is to work to modify or develop DSLs within the algebraic Julia suite of software. And from our last update, we've developed a cellular sheaves DSL, which allows for ease of use for users less familiar with programming libraries.
All right, so let's go ahead and look at a progress update of what we've been doing so far. So a little update on algebraic optimization. I don't think we mentioned too much about this in our last presentation because we hadn't started it yet, but we've currently completed the stellar sheaves macro, which is the core component we wanted to do in algebraic optimization. And this one's going to use ML style versus PEG as we did in the past because we saw some benefits with this. Likewise, or furthermore, Dylan finished working on the CATLab tutorial documentation for the program macro to make that a little bit easier to understand because it was built a little bit more of a while ago. Additionally, the Decode's VS Code syntax highlighting extension was also finally completed. So let's look at the features overall, the completed features overall. Decode CSL, built on a parsing expression grammar based parser, is completed. The syntax highlighting extension for the string macro is completed. The CATLAB program DSL interpreter tutorial page is also done and PR'd. And the algebraic optimization DSL for Seller Sheaves is also completed as well.
So to go over our individual contributions, I mainly worked on building the peg grammar or like the syntactic analysis for decapodes, as well as the CATLAB documentation. And I did a little bit of the cellular sheaves front end.
Yep. And as for me, I worked on more of the semantic analysis for decapodes, so helper functions for the parsing expression grammar, as well as decoration for the abstract syntax tree. Furthermore, I worked on the syntax highlighting extension for decapodes and the cellular sheaf macro, specifically more of the constructor backend and the construction of the abstract syntax tree are this ADT structure.
And now we'll be going over the functionality. Um, so to start with, I'll be going over the decapodes. We have our top level rules, so like taking in the overall expression, lines, and then statements under the lines different types of terms. And then we have comments, which are meant to be ignored by the parser. We have these type assignments through judgments. We have our arithmetic operations and equations. So like we have derivatives, we have like equations, and then like the following binary operations. And we have like composition syntax and like regular function call syntax. And we have like the list of characters we're allowed to use for the DSL peg. And we have these helper functions that help us like returning these different types of like the expressions or aptitudes. And we have like our macro call, which takes it in the decapode string and kind of calls macro. And now we'll be going over to the cellular sheaves.
Yep, let's take a look at that really quickly. So let me see here. All right. So give me 1 second to move my screen out of the way. All right, perfect. So this is the tests for the Seller Sheaf macro. I know Dylan went and looked more into the source code, and the importance of that was that a big part of our project was demonstrating the benefits of a PEG versus ML style. For the Seller Sheaf, it was more focused on just the benefits or the idea of just abstracting something in general. Since this is I guess a new macro, a new DSL compared to decapodes. So instead, let's just look at the test and get an idea of what this actually does in the first place, right? So here is a test for constructing a triangular sheaf. And let's see how this works, right? So the first thing we can do is we can define our restriction maps. Here we have A, B, and C, and these are going to be matrices. You can pass them into your cellular sheaf as arguments, or your cellular sheaf macro as arguments. If they're not matrices, this is going to throw an error. So your restriction maps need to be matrices. Then we'll be inside our scope of our macro, and we can do a few things. So we've defined our restriction maps. Now we need to define or declare our vertex stocks. We can do that by the following, where we declare some sort of symbol or identifier followed by the type assignment. In this case, it's a vertex doc, which is so far the only supported assignment or type within the macro right now, which is or the only thing necessary right now. And you can define stock as well as its dimension. So here we're declaring three vertex stocks X, Y, Z, which is declaring essentially three vertices that hold some sort of vector space or data space in them, right? Next thing we can do, which is really crucial and important, is we want to essentially gather the relationship between our vertex stocks and our restriction maps that map together to the shared or like global spaces and our edge stocks. And we can essentially draw this out as a system of equations, which makes this really easy because we can look at the first one here and we can see x is equal to y. This is essentially just saying x or vector x is incident to vector y. Likewise, we can say, not vector, vertex x is incident to vertex z, and vertex y is incident to vertex z. So this kind of just draws out our triangular sheaf here. And then we need our mappings that are going to map to our shared spaces. So we can see that this is our mapping, our restriction maps A, B, C, and we can see how we can map them out. So um, a maps X to this shared space and B maps Y to this shared space and likewise to the other ones. And the great thing is we never have to deal with declaring edge stocks because this can be easily inferred from your restriction maps and your vertex stocks, which adds a little bit more discipline and kind of prohibits the user from making unnecessary errors. And we can see how this is going to go and be transformed into an abstract syntax tree that's then going to be decorated and type checked and gives all this good discipline things that makes productivity easier. And that's going to go to generate this code here. We can see it's the same thing as what we have here, but it's worth noting that this is a lot more easier to read or more intuitive. So yeah, that's the Cellular Sheaf macro, and I'll stop sharing. And yeah, thank you. And